Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode challenge 1408 string matching in array. It's clear that it is clear that this problem belongs to the string matching category, and this question has been asked in Google 4 times in the last 3 months, and it is also marked as easy, so it's a good problem for beginners. Let's have a look on the problem statement. Here we are given an array of string words, and we have to return all the strings in words that is a substring of another word and return answer in any order. So first of all, understand what is a substring. Let's say the word given to us is superhero or just super. In this word, if I just take a slice of characters, let's say if I pick this slice UPE, then this is a substring. If I pick SU, that is also a substring. PER is also a substring. If I choose SER, S, then ER, this is not a substring. Those characters should be contiguous. Okay. Now let's try to understand the problem statement with the help of an example. In this example, this words array is given to us, and this is an array of string, and we have to pick all the ith word which is a substring of any other word. Let's say any other word is J. So how do we do that? Let's say mass we are picking as ith word, and this is not a substring of any other word. Mass is not a substring of S, as, hero and superhero. Okay. Now consider as my ith word. This AS is the substring of this word because this is coming here, and this is also a substring of, no, this is not a substring of any other word. Okay, so this as will be added to my answer. Okay, now consider hero as my ith word. This is done. Hero is a substring of, not a substring of mass, not a substring of as, but it is a substring of superhero. So hero will also be considered as my answer. So these two words are the substring of any other word. As was the substring of this word, and hero was the substring of this word. So these two words will be added to my answer. So my answer here is like this. This is the answer. And what operation I did is, I picked all the word which is a substring of some other word. Okay, it is saying that it is another word. It means that I is not equal to J. Okay, so how do we do this problem? Firstly, have a look on the problem constraints. Word.length. This array length is going till 100. We can have maximum of 100 words, and every word is of length 30. And every word is consisting of lowercase English letters. Every word is unique. So as the problem constraints are not too high now, firstly, let's try to have a look on the brute force. Brute force means whatever is said in the problem statement, just do that. Just check every word which is a substring of some other word. And how do we check every word? To check every word, it means we need to make a one iteration. Let's say I'm doing this iteration using I pointer. If I'm picking any ith word, I need to check any other word. And that other word, let's say that other word is J. That other word should not be the same word. So J can be from this array, but J is not equal to I. All the words apart from I. It means if we are picking this word as I, I'm going to pick all of these three words as J. Or if I'm picking this word as I, these three words will be picked as J. It is clear that we have to use the nested loops. What is the first loop? First loop is going from 0 till n-1. All the words we need to cover. And what about J? J is also going from 0 to n-1. All the words I'm covering. But if I is equal to J, in that case, do not do anything. It means only process the other word, only process J which is not equal to I. So firstly, let's just have a look on these two loops. This is the first loop for ith word, second loop for jth word. I will see whether the I is a substring of j. How can we check that? Whether j contains I word. If jth word contains I word, then what I will do is I will add I to my answer. Answer dot. So this much we have to do. This is my for loop and these are my nested loops. Okay. So let's say if I is this word. So this word is being compared with mass, and we will check whether the mass contains as. Yeah, it is giving yes. So I will add as in my answer. So this first loop will go n times. This will go roughly n times. So in total it is going to be n square time. And now we need to see how the contains function is working. Contains function, let me zoom it out. It is mass mass dot contains as. So this is something. This is the text and this is my pattern. And my question is whether this pattern exists in this text or not. Okay. And for this, you can either compare whether this as is coming at this position. If it is not at this position, then start comparing from next character. What I'm trying to say is that the naive algorithm of pattern matching. Let's say this is my first word and this is my second word. I will take one pointer for this and one pointer for this. I will see whether I and j are matching or not. Or let's say I'm taking one more pointer k. K is from where I have started comparing. I and j are not matching. Okay, ignore it. Start from the next one. Move the k and the I to the next one. K and I to the next one. Start comparing from here. A is matching. S is matching. It means, yeah, we have found the result because j have covered all the length. This is something checking the pattern in the text. And what is the worst case of this algorithm is, let's say this is of size n and this is of size m. It is going to be n into m in the worst case. Because let's say every time the last character is not matching. Problems like this, A, and then B, and then A, B. So in this time, firstly we'll be matching this one, and then I will do this one, and then this one. So every time we are comparing repeated characters in the naive algorithm. So that's why it is not optimized. It is going in a quadratic form, n square time. But for now, don't worry about the algorithm. You can utilize the inbuilt function. Let's say I have utilized the string inbuilt function which is contains. And how this is better? Because inbuilt functions are not with a very basic naive algorithm. They have some advanced algorithm. Let's say there is one algorithm in the pattern matching which is KMP algorithm. I will try to prepare a separate video on this algorithm. What this algorithm does is it do the pattern matching in n plus m time instead of n square time. Utilizing this inbuilt function will give us the better result. Otherwise, if you want to write your own algorithm, own comparing algorithm, just try with the naive algorithm. Because the problem constraints are not too high, it might submit. Otherwise, like I will just prepare another video on KMP. That might become a medium level problem. For now, just go with this n square, and you can assume that this contains function is utilizing some better algorithm of pattern matching. So you can assume that it is going to be n plus m, n cube time complexity in general, and no space complexity. Let's have a look on the code. Here, this is the words array, and we need to get every I, which is a substring of some other j. This is for the ith loop, this is for the jth loop, this is the ith word, and this is the jth word. Now we need to see whether any other word, which is s2 contains s1. This is the inbuilt function, but if you want to write your own function, you can write the naive function of string matching. What is this naive function? Whether this s2 contains this s1 or not. S2 I am calling text, this is I am calling pattern. Okay, if this is matching, just capture this ith word. Now this is the main part of the algorithm, which is the naive string matching algorithm. This algorithm is not efficient, giving n-square time. But to do it in a better way, we have some other algorithms like KMP. So here what I am doing is, I am maintaining 2 pointers. One pointer is for text, one pointer is for pattern. I pointer is for text, j pointer is for pattern. If at any moment j is becoming equal to the length of the pattern, return true. And what I am doing is, keep incrementing both the pointers I and j if the characters are matching. If the characters are not matching, just start one step ahead, one step after where you have started initially. Initially you started with k. This k pointer is for that. K equal to 0 means we are starting from the starting of the pattern. Let's say in this case mass, we are starting matching from m. It is not matching, then we'll start matching from a. In this case, I is at 1, j is at 0, and we'll keep on matching the character. And if the j is becoming equal to the pattern dot length, yeah, we have found the substring. Okay. If I submit this is a bit slow. Only beat 7%. Let's submit the inbuilt function. Inbuilt function might be better. s2 dot contains, yeah, inbuilt function is better because that is not written with this naive algorithm in the mind. Okay, but yeah, it is working. Problem is getting submitted because the constraints are not too high. That's why, and it's a good easy problem for beginners. Okay, I hope you understood the problem. If you get any doubt, you can comment down below. I will try to address your questions. Bye bye. Thank you.